Good afternoon. My name is Samya Akhtar, and this presentation is my interim progress demonstration for the Computer Science Final Project module. My project is titled ShareWare, a mobile application for uterine health awareness. In this presentation, I'll discuss the problem background, stakeholder analysis, refined requirements, system design, development progress, and updated project timeline. The motivation behind this project comes from the fact that many uterine conditions, including cancers, are often detected at later stages. This is largely due to symptoms awareness and cultural stigma, which can delay women from seeking medical help. In the UK alone, there are around 9,800 new uterine cancer cases each year, and research shows that South Asian women face additional social and informational barriers, which further increases the risk of delayed diagnosis. The main aim of Share is to develop a user-friendly and privacy-focused mobile application that promotes uterine health awareness and encourages early help seeking through symptoms recognition without providing medical diagnosis. Share addresses these by offering trusted, evidence-based health education, enabling regular and private symptom tracking, and supporting women in preparing for more informed GP consultation. This diagram presents the key stakeholder using the onion model, organized by their proximity to the system. At the core is the shareware mobile application itself. Surrounding these are the users and administrator who directly interact with the system, followed by the indirect beneficiaries and the broader environmental influences. Um, this slide explains the key stakeholder involved in the Share project using the onion model, which helps distinguish between direct users of the system, indirect beneficiaries, and the wider contextual influence. At the core of the system is the Shareware mobile application itself. This is the central platform that delivers health education, symptoms tracking, and awareness feature. The primary stakeholder who directly interact with the system are women users and the admin or health educator. Women users are the main users of the application, then needs strongly influence the design, and particularly the focus on privacy, anonymous symptom tracking, and a simple non-clinical interface. The admin or health educator is responsible for managing and updating verified educational content. This role influenced the inclusion of a backend content management structure and the decision to rely on trusted health sources. The containing system includes stakeholders who do not directly use the application but benefits from its operation. This includes healthcare professionals such as NHS GPs, who benefits from better informed patients and clearer symptom communication during consultations. Families are also part of the containing system as they benefit indirectly through the increased awareness and support for women's health decision. Additionally, usability test participants contributed feedback that help improve accessibility, navigation, and overall user experience. Finally, the wider environment includes regulatory bodies which influence privacy and data storage decisions such as GDPR compliance, the academic environment which provided ethical oversight and scope validation, and social and cultural factors which shape the culturally sensitive and inclusive design choice. Um, Together, these stakeholders significantly influence both the functional and non-functional requirement of the shareware system. Um, this slide summarizes the formal, functional, and non-functional requirements defined in the PPRS. Functionally, Share provides an education hub, anonymous symptoms login, mood tracking, risk awareness scoring, visual trends, GP visit preparation, notification, and support resources. Non-functional requirements focuses usability, accessibility, performance, privacy, maintainability, and cross-platform compatibility. These requirements are directly aligned with the project aims and stakeholders' needs. Um, Uh, the majority of the functional requirements have now been implemented. Core features such as symptoms login, education hub, risk awareness scoring, trends visualization, notification, and privacy focused local storage are complete. Remaining work focus on the final UI polish and performance optimization and incorporating usability feedback. Um, these are the non-functional requirements implementation. In this slide, I'll briefly show the evidence of the key non-functional requirements implemented in shareware. Because the app is not only about the features but also about the quality, usability, and privacy. Firstly, usability. The app uses simple navigation, clear labels, and minimal steps. So it works well for mixed age users, including those with limited digital confidence. Secondly, accessibility. I included an adjustable font sizing and ensured readability with a clean layout and high contrast so the content is easy to read. Thirdly, performance. The UI is lightweight and Flutter, and pages are designed to load quickly. I'm still doing final optimization and testing, which is why the performance is marked as partially implemented. For security and privacy, Share does not require user login and stores all symptom entries locally on the device, which reduces risk and supports privacy. Finally, the maintainability. The educational content can be updated through the Django admin panel, and the app runs on both Android and iOS. A small part of it is still being finalized, which is why maintainability is also marked as partially implemented. Overall, most non functional requirements are implemented, and my next focus is final performance testing and final refinements. This use case diagram models how the users and administrator interact with the shareware. Women users can access educational content, log symptoms, view trends, and risk awareness, prepare for GP visits, and access supports resources. The admin user manages educational content through the backend system. Um, this uses this use cases may directly to the functional requirement refined earlier. Um, and here's the activity diagram for my Shiver app. The activity diagram illustrates the high-level user journey within Shiver. User open the app and then view the dashboard and select a feature such as symptoms, login, education, or GP preparation. This diagram focuses on core interaction rather than detailed interface. Behavior, demonstrating how the system supports awareness and decision making. And this diagram shows the overall system structure. The Flutter based mobile application served as the front end, while Django backend supports admin content management. Education content is retrieved from the backend, while um, all user symptoms data is stored locally on the device to ensure privacy and GDPR compliance. Notifications are handled through device-based scheduling, maintaining a privacy-first design. And here's the key logic. Shira uses a simple, transparent logic rather than diagnostic algorithm. The risk awareness score is generated based on the frequency and the duration of the lock symptoms and map to low, medium, or high levels concern. Um, the score is a non-diagnostic and it's designed to encourage reflection and timely GP consultation rather than provide medical consultation. And then you can see the visual trends, visual graph of the symptom trend. Um, At this stage, the core prototype is fully functional. Key screen including the education hub, symptom tracker, trends view, and GP preparation summary have been implemented using Flutter. The system has been tested on Android devices with usability and accessibility consideration incorporated throughout developments. This concept outlines the planned project timeline across 2 semesters. It includes requirement elicitation, design, development, testing, and documentation phase, providing a structured overview of project management. And the golden color diamond shape button indicates the milestone. Most of them are completed. I have two remaining milestone in the upcoming weeks, and currently I'm on track with my Gantt chart. This slide reflects the progress made since the PPRS submission. Core development task has been completed, and the timeline was adjusted slightly to prioritize usability, inclusivity, and system stability. The remaining phase focus on final testing, optimization, and report preparation. Um, this slide shows the UI/UX design of Sheware created in the Figma, which was used to plan and validate the user experience before and during the development. The first screen represents the onboarding and welcome flow, designed to feel calm, supportive, and non-clinical. Um, this is important because the topic of uterine health can feel sensitive, and the design aims to reduce the anxiety rather than increase it. The next screen shows the core user journey, including symptom login with simple checkboxes and minimal output. Um, a visual symptom trends screen to help user notice patterns over time, a clear non-diagnostic risk awareness display that encourage reflection rather than self-diagnosis. The overall design focuses on simplicity, clarity, and accessibility with minimal clear text, clear icons, consistent layout. The Figma designs guided um, the implementation of the final app interface and helped ensure usability for mixed age users. Um, to conclude, this slide summarizes the key challenges, reflection, and the next steps for the Share project. One of the main challenges throughout the development was balancing user privacy with meaningful health insights. Because Shiva is designed as a non-diagnostic and privacy-first application, all data is stored locally and no login is required. Mm, this influenced how features such as symptom trends and risk awareness were designed, ensuring they remain informative without compromising um, user confidentiality. Um, and another key challenge was inclusive and cultural sensitive design. The application is intended for women from diverse age group and backgrounds, particularly South Asian women in the UK. This required careful consideration of the language and interface simplicity and accessibility to ensure the app is approachable and easy to use. Reflecting on the project, a strong user-centered approach guided all major decisions. Ethical consideration and stakeholder input played a central role in shaping both the system architecture and feature set. The reinforced this reinforced the importance of designing digital health solutions that prioritize trust, safety, and user empowerment. Looking ahead, the final stages of the project will focus on usability testing, performance optimization, and completing the final evaluation and documentation in preparation for the submission. Overall, she will demonstrate how a carefully designed digital health application can promote awareness and encourage early help seeking behavior and support users in a respectful and privacy preserving way. Thank you